In this video, we're going to take a look at the converse of the Pythagorean theorem as well as the triangle inequality property, both of which we looked at earlier today. Basically, Pythagorean theorem, as you hopefully will remember, is going to be a squared plus b squared is equal to c squared. We've looked at this theorem, Pythagorean theorem, in terms of solving for one of the sides given the other two sides. But when we look at the converse of the Pythagorean theorem, we're actually given all three sides. So for example, a might equal 6, b might equal 8, and c might equal 10. What we do not know is whether or not this is a right triangle, so if this is a right angle. With using the converse of the Pythagorean theorem, we're just going to plug the sides in. So we're going to look at 6 squared plus 8 squared, and we want to know, does this really equal 10 squared? So basically, if I just take this, if I square both 6 and 8, I'm looking at 36 plus 64, and I'm going to ask, does that equal 100? Well, 36 plus 64 equals 100. Well, that does equal 100. So since that works, yes, this is a right triangle. Most times, it actually will not work out. So just to show you, let's say this is 5, this is 9, and maybe this is 10. We're going to look at this and say, does 5 squared plus 9 squared equal 10 squared? 25 plus 81 equal 100. When I add these two together, I am going to end up with 106. Does that equal 100? No. So this is going to be not a right triangle. As we mentioned in class, this is how some carpenters and people in construction will check and see, our buildings at right angles, our door frames at right angles, because they'll measure the length, the width, and then they'll also check the diagonal to make sure that this is indeed, that it's all squared up and at right angles. The last property we're going to look at is something called the triangle inequality property, which we also looked at some in class today. Basically, what this property states is the sum of two sides must be greater than the third side. Otherwise, a triangle can't be formed. So basically, what we looked at in class is if you're dealing with a little piece here, and a little side here, if I give you something with the length of this, there's no way that's going to connect. Similarly, if I give you this distance, if I give you this distance, and I give you this a piece that's exactly equivalent to it, there's no right place to go. There's no way for it to form a peak. So basically, if I'm going to add two sides together, it always has to be greater than the third side. So for example, if I gave you one side equals 3, another side equals 5, and the next side is equal to 1, this is not going to be a triangle. Because if I look at 3 plus 1 is 4, it's less than 5, so it's not a triangle. On the other hand, if I let A equal 3, B equal 5, and C equals 6, if I check, 3 plus 5 is 8, it's larger than 6. 3 plus 6 is 9, greater than 5. 5 plus 6, greater than 3. So this is a triangle because of this theorem. So both these properties are fairly simple. Pythagorean theorem we already took a look at. Triangle inequality property is as simple as adding two sides, the sides together. So the math involved isn't that great, but the reasoning is. So hopefully this has been helpful for you, and looking forward to using these properties.